All right. So the next chapter has a lot to do with angles of polygons. Talks about all the different types of quadrilaterals as well. All right. But today we're going to learn something very simple for different shapes, whether it's a triangle, quadrilateral, pentagon, hexagon, all the different types. You can calculate the measure of all of the interior angles. And just let me show you how simple that is. All right. For example, just to look at number 3, that's considered a quadrilateral. Some of you might say it's a trapezoid. All right. So what are the angles, or what are the measures of the interior angles going to add up to? Why is it 360?
We know.
240. What do you think? It is 360. What do you think?
60.
Now, again, why is it 360 though? That's the question. It's just made up of 2 triangles. Look, very, very simple formula. Very simple. All right, so let's look right here. Again, this isn't part of the homework yet. It's just a matter of me trying to explain to you how they come up or how they develop this. All right. That, if you cut it into 2 triangles, we already proved that the angles of a triangle always add up to what? 180. So if it's 2 triangles, then the quadrilateral, the angles would add up to 360. Now let's look at, for example, the next one. All right. So now you have what's referred to as a hexagon. The measure of the interior angles of a hexagon would have to add up to what?
480? 560.
Wow, you guys are just throwing out numbers. Pretty good.
540.
Why 540?
Because it's it makes 3 triangles.
Yeah, it makes up 3 triangles. It doesn't matter how you cut it. You just pick a vertex, and then you divide the hexagon into, in this case, 4 different triangles. All right, so let's look at it. So 4 sides means there's 2 triangles, and 6 sides was equal to what? 4 triangles. So now let me see if I can do this new notability. Right? So that has how many sides now? 5 sides. All right, so that would be 3 triangles. All right, so Pentagon produces 3 triangles. All right, so what is the rule now? You should be able to discover the rule for, let's say, an n-gon. All right, what's the formula for discovering the interior angles of, let's just say, an n-gon? N-gon just means any number of sides. Tell me, Charlotte.
N minus 2. Like the number of sides minus 2.
Then
Equals the number of triangles.
Then I want the sum of the interior angles.
Oh, times 180.
Yeah, look guys, that wasn't that difficult. All right, listen carefully what you just said. All right, there's always 2 less triangles when you draw a n-gon. All right, so the formula for the sum would equal n minus 2 times 180. All right, that's the sum of the interior angles of a convex. All right, and then I should probably go back and review with you the difference between convex and concave. All right, these are all referring to convex. All right, now let me just show you what something concave would look like if I did something like this. All right, that would be considered what? That would be considered concave. And let's just give you the formal definition. The formal definition is when you draw the diagonals, please watch now. If I'm drawing the diagonal, which would be just simply a line from one vertex to the other, see how these diagonals are on the inside. But if I draw this diagonal, that diagonal is what? On the outside. So anytime you draw a diagonal, if it's on the inside it is said to be concave. All right? Or I mean convex. If you're drawing the diagonals and one diagonal ends up on the outside, it is considered concave. And the rule does not apply to concave polygons. The rule only applies to what? Convex. All right? It only refers or only works if you're referring to convex. All right? Now that you know the difference between concave and convex, all right, the next thing is we're sometimes going to call a regular pentagon or a regular hexagon. So if I drew a regular, I'm going to try to draw a regular hexagon. It's not working so good. All right, there's my regular hexagon. Why is it called regular? Because what?
It's not concave.
No. Hey, just ignore him. Try, come on. It's called regular for what reason? The sides are equal, exactly. And what else?
Both sides. It doesn't. No side sticks out of the triangle.
Yes, so it has to be convex. Yes. So if something's regular, you say that the sides are equal and the angles are equal. So in this case, I tried to draw a regular hexagon. So what's true about all the angles? They are congruent. So now, how do I find the measure of each angle? What would I do?
You do 6 minus 2 and then times 7.
Yes. Well, that's not the measure of each angle, though.
It would be 540 divided by 6.
So I want the formula now. That's exactly correct. N minus 2 times 180 divided by N. That is the measure of what? The interior angle. That's the measure of the interior angle. If it is regular. And again, it's not really something you have to write down or, memorize, right? All of the angles add up to N minus 2 times 180, correct? And if they're all equal, then you just divide by what? Divide by N. It's exactly correct. All right. Does anybody have any questions with that? All right. Now let's just go through. And here's one other thing now I want to show you. All right. Now I'm just going to go back to this part right here, my hexagon, since it's drawn. All right. And what I want to do is I'm erasing the interior angles. And there are interior angles and then there are what? Yeah, interior and exterior. So here's something to me that I thought was a little weird. All right. The angle I just created is a what? Exterior angle. Now, for me, I thought over here if I drew that, that's another exterior angle. Do you agree? And then this angle right here is vertical with that angle. So that's not referred to as an exterior angle. Do you agree with that? All right. Yes. Now, here we go. For this part right here now, listen, this is an exterior angle. And this also is an exterior angle. To me, it seems as though if you have a hexagon, there would be what? 12 exterior angles. Do we agree?
So you would just double the angle?
No. Listen, I just want you to look up here. There seems to be 2 exterior angles for each angle. Does everybody agree with that?
Yeah.
But for whatever reason, all right, and I'm not even 100% sure why, that if these are the exterior angles right here, they're equal. All right? I don't know why, but they only include one of them. All right? And I think maybe possibly because there are 3 what? These are called the vertices. All right, so there are how many vertices? There are 6 vertices. So the only thing I can come up with is if there's 6 vertices, there must be 6 exterior angles. All right, me personally, I thought it would be what? 12. Right, but it's not. All right. Now, there's something very unique also here is that regardless of how big the shape is or how many sides, the exterior angles, all right, the exterior angles have a sum of 360 degrees. All right, the sum is 360 degrees. The interior angles, all right, the interior angles can change, all right, the sum wise, but the exterior angles always equal 360. All right. So I think we've discussed everything really now in this unit. Yes.
So the sum of all the exterior angles?
That's
like,
exactly right. The sum of, now, let me just go ahead and finish this now. All right, let me just show you. I probably ended that a little soon. But look right here. So that's an exterior angle. Now watch. I'm going to draw the other exterior angle. That's the other exterior angle. That's another exterior angle. Notice how I'm going in the same direction. That's an exterior angle. That's an exterior angle. And there's the other exterior angle. So 1, 2, 3, 4, 5, 6. All right. But I've also said that if I draw something maybe like this, and I went the other direction, that's 1, 2, 3. So everybody see what I'm doing, right? 4, 5, and 6. So it's whatever direction you're going. All right. So again, I just thought it was strange that they don't say that there are what? 12 exterior angles. To me, it seems like that should be the case. All right. What?
Is this, so all of them add up to 360, like all polygons?
Yes.
Okay.
Exactly. The sum of the interior, the sum of the exterior angles of any end-on. All right. Convex is what we're talking about. Not yes.
So it would wind up being like all 6 equal 360.
That's exactly correct. That's 100% correct. And again, I always just thought it was a little weird that they would say 6 exterior angles when I can obviously count what? 12. All right, but if somebody says there are, if you have a hexagon, they say that you have what? 6 exterior angles and 6 interior angles. All right.
So like, since it's like a regular hexagon, does that mean that all the exterior angles are equal?
Yes. All right. So now let's try to answer some of these questions so we don't have so much homework. All right. So if you have a decagon, how many sides is deca?
10.
10. All right. So let's use our little formula. All right, and tell me what the sum would equal. Somebody.
1,040.
How much?
1440.
1,440 degrees. All right. Remember, the key to getting better, and by the way, I looked over everybody's grades, and I'm pretty happy, and I know some of you are not happy. All right, so we got to change things up. All right, now I want to say this too again, and I know you guys know this already, but does everybody understand we have Thanksgiving? And we also have Christmas. So we don't have as much time for tests. Everybody with me? We don't have enough. We don't have as many tests this 9 weeks. So that's all the more important to do well on each test. Which brings me to my next conclusion. You understand if you mess up a test, it's harder to bring your grade up. You understand that? All right, so I imagine we'll probably have 3 tests. That's probably it. All right, so that means if you do well on the 3 tests, to me, it's easier to make an A now. All right, so you just have to stay with me the whole time. And again, remember, the nice thing about St. John's is we send over semester grades. Everybody with me? So if you made a B, make an A, and make an A on the exam, and now you have an A average. All right, is everybody with me? All right, please keep up. All right, and speak up if you want something different. All right? So back to the Pentagon. Pentagon has how many sides? 5. So then we do the formula, 540 degrees. And honestly, guys, I tell kids all the time, I think this chapter is, again, not as easy as the last chapter, but pretty easy. All right, it's pretty easy. All right. Now, here we go. Down for number 3 now. This is a quadrilateral, correct? So if it's a quadrilateral, the interior angles add up to what? 360. Now it says find the measure of each interior angle. All right, so if it's 360, how many x's do we have?
10.
So 10x is equal to 360, so we know that x is equal to
36.
36. All right, so now you know one angle, or you should say angle x, is equal to how many degrees? 36 degrees. Angle y is 72 degrees, and angle w is equal to 108 degrees, and angle z is equal to 144 degrees. Again, guys, I just think it's really simple. All right. Anybody have any issues with that? I'm agreeing. It's easy. All right, let's check out 4. All right, I kind of messed 4 up again, but we know it's a what type of shape? Hexagon. And you'll do it enough pretty soon to just remember that a hexagon has what? The angles, the sum. The sum is what? Say it again. 720. 720, because 6 minus 2 is 4. 4 times 180. 720 degrees. All right. Now, obviously, it's just easy to write this equation. So how many x's do we have? 6x. All right. Now let's add the numbers. Now, some of you guys now, come on. 6, negative, I mean, they're not that hard to just go right around. What do we got? 6x what? Is that right? 0? Equals 720. So x is equal to, come on guys, 120. So x is 120. So now start at A and go all the way to F. Don't be lazy. Angle A equals angle B equals angle C equals angle D equals angle E equals an angle F. Put them all down. Especially those of you guys who need to make an A. Write everything down. Okay. Everybody happy with that? Somebody tell me quickly number 5. Somebody said 157.5. Right? There are how many sides? Come on, guys. Again, don't take anybody's word for it. You get out your own calculator and you do your own work. All right, I'm just asking for an answer. That's all. All right, if you don't know how we're getting that number, now's the time to speak up. What is it? Somebody said 157.5 degrees. 157.5 degrees is the measure of each interior angle. Is that correct?
Yeah.
All right. Given the measure of the interior angle of a regular polygon, find the number of sides. All right, so this is just going to require a little bit of algebra, and then I'll show you a shortcut. All right, but let's do the algebra first. All right, so here we go. If the interior angle is 150, it would be 150 is equal to n minus 2 times 180 divided by n. Did I agree with that? And I'm sure everybody's looking at that just going, well, the answer is 12 then, right? Right? 12, you can just look at that and say 12, right? Agree?
Yeah.
All right. Multiply both sides by n, right? So you get 150n is equal to, distribute the 180. 180n minus 360. So that means 30n equals 360. So n equals what? 12. That's the math. Everybody okay with that? So now let's do number 7. 170 degrees is equal to n minus 2 times 180 divided by n. Obviously, that would be 36, right? Double check my math, please. All right, everybody getting 36 for that? Not bad, right? All right, now let me show you how I was able to get those numbers without actually doing any math whatsoever. All right, I think that's kind of important. All right, now those are the formulas, correct? All right, so now I'm going to draw another. All right, there's my regular pentagon. Is everybody with me on this? All right, now I'm going to draw. So this over here now is considered the what? And this is considered the what? What's true about the interior and exterior?
Equal 180.
Yeah, that's a 180. Does everybody agree with that? All right. So to me now, listen carefully. So they gave me an interior angle of 150 degrees. So I put 150 degrees here, right? So what's the exterior angle? 30. Do you agree with me? Now, the angles, the exterior angles always add up to what? 360, right? So if the exterior angle is 30, then 360 divided by 30 gives me the number of sides. So 360 divided by 30 is what? Come on, guys. 12. All right, so how did I get 36 real quick? What did I do? 180 minus 170, which is?
10.
And then?
360 divided by 10.
Which is?
36.
There you go, guys. All right, everybody see that? All right, I don't really care how you do it. I just think using the exterior angle is much easier than using the interior angle. Does everybody agree with that? Everybody see what I did? All right, and again, it doesn't matter how you do it. All right. So that's the shortcut there. All right. Now let's take a look at number 8. So now they're just giving you all of the what? They're giving you what type of angles? The exterior angles. So we know they add up to what?
360.
Be careful. They add up to 360. So come on now, guys. I want you to add up the x's for me. How many x's do you see?
2.
No.
4.
4x. Now add up the numbers for me. Now, what I'm trying to get you to do is, yeah, be careful. 2 and 88 is what? 2 and 88 is...
90.
Some of you guys just use your calculator. 90 plus 10.
100.
So there you go, guys. Come on, practice your mental math. Obviously, we need lots of practice. Right, Charlotte?
Yes.
Equals how much?
360.
360. All right. All right. Now, 4x is equal to what? I'm not doing it for you guys. Who said that? Wow, that's what I figured. 208. So now, wow. 20 divided by 4. 8 divided by 4.
2.
Wow, see how great you guys are? X equals 52. All right, now in this particular case, it just says find x. It doesn't say find each individual angle. So we're good. Find x. All right? Here we go. Take a look now at number 9. Same principle. How many exterior angles? So tell me about the x's. 4x again. Then what? Equals. Now look, everybody look up here because we're working on mental math now. Does everybody see it's obviously divided by 4 would be a better option?
Yes.
So I want everybody to say that's just what? X plus 22 equals 90. 90 minus 20.
70.
70 minus 2.
68.
I'm trying to teach you guys how to do mental math better. Some of you guys are, sorry, pretty pathetic. Yeah, I know. Wear that with a badge of honor. I like that. I'm bad at mental math. All right. Right. We've got to, yes. All right. Any questions?
Why did you do 4x plus 88?
Because I added up the x's, right? 1, 2, 3, 4. 79 minus 1. Are we okay with that?
Yeah.
And then plus 10.
Oh, I guess. Yeah.
All right, here we go. Now, 10 and 11, again, it says, find the measure of each exterior angle. All right? Now, notice of this important word, regular polygon. Obviously, they all have to be equal in order for that to work. All right, so they have to say it's regular. All right, so the exterior angle of a regular quadrilateral, and a regular quadrilateral is just a what?
Square.
Square. Thank you. Wow. So the exterior angle would be how much? No. 90. Wow. 90 degrees. We're talking about the exterior. That's the formula. Perfect. So octagon would be, you guys doing 360 divided by 8.
45.
1,080.
Emily,
It's the same.
360 divided by 8.
It's the same.
The exterior angles. I know I was going to point that out, but some of us are slower than others.
Oh.
360 divided by 4, and I just asked you to do 360 divided by 8.
45.
I don't know what you guys are
You could have
doing.
just divided 90 by 2.
I said it before.
I just have a calculator.
Yeah, I just used the I used my forehead.
Like, no problem. We're on the left.
You'll do it faster than something. I got I made a forehead with my forehead on my calculator. I made a forehead with my forehead on my calculator.
Go, get to work. Finish it up. It's very simple. Very, very simple. All right. Hey, you have your calculator. I don't mind you use your calculator, but listen. Hey, guys. Hey, listen, I know it's been a while since you had to listen to me, but I'm telling you right now. Hey, I mean it now. Some of you guys, if you looked at your grade, you shouldn't have been happy. Some of you. All right, so that means get started right now. We have a short 9 weeks. We have a short 9 weeks. All right, we don't have a lot of tests.
Well.
Look it up. You have a